almost lost the tip.
Not very well.
All right. Okay, so don't forget exam when?
Friday.
Tomorrow, Friday. Or Friday, right? Now if I say, I have one of the students said, can I just take one piece on Thursday and then the second portion on Friday? And the answer is no. Okay, but I have that question. All right, so, well, I know you're still working on the review, but overall, as a concept, what we have to do for, I don't know, maybe L'Hopital's rule or some other things, are you okay? Because I cannot spend the entire period right now doing review again. But if there's something you want to refresh, one thing, let's talk about one thing. Let's do it then. So, Minigo, anything from you?
Sorry. Stephanie?
You can look at each other and ask the question. Do you have any questions? Alright, to be quiet. Okay, so now, what did we do last time? What did I do as the last problem? Graphing? Oh, we did graphing. Alright, so we did graphing. Now, do you need anything, let's say, with the limits? Like L'Hopital's rule or something?
If all of you pass your tests. Okay.
So let me look through my notes quickly and I'll put maybe one problem with L'Hopital's rule and we'll see. So let's take a look at this problem. We'll start with something a little bit easier. So we have limit of sine of 4x over tangent of 5x when x is approaching to 0.
Yes.
So first we're going to substitute. So sine of 0 is 0 and tangent of 0 is 0. So we have 0 over 0. And probably the easiest way to do it is just go with the L'Hopital's rule. So as I said yesterday, so please again, make sure you will not take the derivative as the quotient rule, right? We're taking two derivatives here, the top and the bottom. So if you take the derivative of the top, you get cosine of 4x, but please do not forget to take the derivative of 4x. So that will be times by 4. Simple composition, but sometimes we overlook and we do not put that 4. Then going with the tangent, what's the root of tangent? Secant squared. So we get secant squared, good, of 4x. And the same thing here, times by, not 4x, but what? 5x, right? Fixing that one. And times by 5. So we'll get to this. Try to substitute. With trig, probably will be easier to substitute instead of simplifying. So cosine of 0 will be 1, right? And secant squared of 0 also will be 1, right? Because secant is 1 over what? Cosine. So as the answer we have what? 4 over 5. Okay, not the quotient rule. Well, let's take a look at one more. So let's say we have x over, and again, you need to know the concept, not memorizing any problems. So this is what we have. And if we substitute, we'll have 0. And tangent, inverse tangent, goes to the origin. So tangent of 0 is 0. Okay. Again, we're speaking about inverse, right? Inverse tangent. So again, we'll go with the L'Hopital's rule. And please don't forget, every time when we take the derivative, we should simplify. It's possible. And again, we'll take the derivative. So derivative of x is 1. Please refresh your tables of derivatives. And there are no inverse hyperbolic function on the exam. So those formulas that I gave you last time, remember on the exam, you don't have to use them. So you're not going to see any formulas as the derivatives added to the exam because I didn't put any hyperbolic inverse functions. Okay, so take derivative of this one. Do you remember the derivative of inverse tangent? Okay, yes, but in the book it says 1 plus x squared. It's the same. Now the other thing what I want to warn you, I had this question today in my other classes, like can we just bring this up because it has a negative first power? The answer is no, okay, because it's inverse, it's not to the negative first, right? So don't move it. So, again one more time, derivative of inverse tangent of x is 1 over 1 plus x squared. But you do not have x. What do you have? You have 4x. So what do we have? We have 1 over 1 plus 16x squared. Do you understand how to get 16? It's what? 4x squared, right? Okay? And still, times by what?
4.
4. Good. And then we simplify it. Now you can substitute right now if you want, not a big deal. Well, let's just simplify. So when we simplify, we will have 1 plus 16x squared over 4. And when we substitute, we'll get 0, so the answer is 1 over 4. Okay, now, the second example right here cannot be done without L'Hopital's rule. This one can be done. Okay? Because we have two different ways of doing this. This is the easiest one if you go with L'Hopital's rule. But for this problem, you can also use the sine of x over x when x approaching to 0. But it will be a little bit more complicated to expand this and work with the variables. So the easiest way to do this is to use L'Hopital's rule. Let's take a look at one more, the last one with L'Hopital's. And I'm just going to come up with something here. I didn't bring my book. I should. I did not. So now I have to think about some example that I can use. Let me think about this. Just a second. I'm trying to think about some extra example, and I really want to have one of those, the last one, so we have something to power. Like, what do we have? Infinity to 0, right? Something like this. So let me see what I can put right here. Okay, let's take a look at this one. When x is approaching to infinity. Now, I'm reminding you just the concept, okay? So when we substitute, 1 over infinity will be what? 0. So you get 1, right? 1 plus 0, and then you get 1 to infinity. So it's one of those problems where you have to bring power down. And what does that? You bring power down? Natural log, good. So as I was telling you, we put the function, just go to y equals 1 plus 1 over x.
Actually, technically 1 to the anything power is 1, so...
Well, we'll see. Maybe you're right, but it's not always true. So I would never say that's the definite statement. Because I don't know if I told you, there are some things that were established many years ago we can challenge with new technologies, let's say. And I heard this on the news, that they say that, remember we saying the speed of light is a constant, right? Well, they're saying it's not true anymore. So they had experiment done, and they're saying that they found that speed of light can be even more faster, like 30 times faster than what we have right now. Depends on what substance, like gas, you can shine the light, let's say. And I don't know, some of the scientists saying, I don't know if it's true, I mean, it's just a hypothesis here. They're saying since now we know the speed is not the constant speed of light, that means there's a possibility that we can go back into the past. I don't know what that means, really. I don't know.
Time travel? That sounds awesome.
I don't know, but that's what I heard. But what I'm saying, there's some concepts, like you said, 1 to any power is always 1. Well, that's not exactly 100% true. Yeah, it's true for some problems, but 100% is not exactly true. So we'll continue with this. So again, I just took this function, and then I'm going to apply natural log. And again, the whole purpose of doing this is to bring that x down. And please, again, use right algebra, because from the previous exam, I saw that some of you still not sure what to do with the logs and the purpose of this whole thing. So we're not working on the limit yet. Now, according to the property, I can bring x down. So it's just x, whatever is here is just in front, then times natural log of 1 plus 1 over x. So we kind of work with the function separately. Now we will go back to the limit. So I have limit of this, x times by natural log of 1 plus 1 over x. And that's what I have to do. Remember, we said before, we're not paying attention to natural log of y. Now we're working with the right side. So when you substitute right now, what do you get? So this will be what? If you substitute? Infinity, right? Then times. If you put infinity here, 1 over infinity is 0. So you have natural log of 1, which is 0. So now we have infinity times 0. And we have to change this infinity times 2 times 0, because you cannot use L'Hopital's rule. And nothing else can be done. So how do we do this? We have to change this to the fraction, right? So we have limit. X is approaching to infinity. And how do we change this to the fraction? Take x. So natural log, we're keeping on the top. Remember I told you, normally we keep something larger on the top because we have to take derivative next. And this one will be 1 over x, like this, right? Where x is negative first power. But please, again, make sure algebra is right. You don't just bring x down and say over x, right? Algebraically it's wrong. So we have to put 1 over x. So now when we substitute right now, you will have 0 over 0. So you change the function, the look, and now we have 0 over 0. We go with L'Hopital's rule. Alright, so here we have 1 over 1 plus what?
1 over x squared.
1 over x, not yet. This is just the first part, right? Yes, no?
Yeah.
And then times by, and now we have to take derivative of the inside. So this is 0. And what's the derivative of 1 over x?
Negative 1 over x squared.
Negative 1 over x squared. Now, some of you saying, like, how do we know this? Well, because of many times we had this, right? So one more time, just quickly. Let's move this up. So if you're looking for the derivative of 1 over x, right? We can change this to x to the negative first power. That's the easiest. You can still use quotient rule here if you want, right? So if you take the derivative, you bring negative 1, you multiply by, you subtract 1. Don't forget the difference between derivative and antiderivative, right? Careful with this. So you get x to negative 2. So the answer is negative 1 over x squared, and that's exactly what we put right here. Okay? And then the good news, right? You're going to take the derivative of the bottom, which is 1 over x. And we just had this, so what's the derivative of that one? Negative 1 over x squared. So, as you see, what? These will be cancelled, right? And what we have limit x approaching to infinity. Don't forget to write limits. 1 over 1 plus 1 over x. And you don't have to simplify this, okay? Just substitute. So what do you get? You get 1, right? But now we're going to run the concept because the answer is not 1, right? What's the answer? E to the first power, which is just E. So it's not true all the time, okay? It's not. So the answer is E. Now, do you understand why E we have? Because remember, the beginning of the question, if I put this back, it says limit of natural log of y. So we have limit natural log of y when x approaching to infinity is 1, right? That's what we have. Because you found it was 1. But you want to know what limit of y is. Just write y. In that case, you have simple equation to solve. Natural log of y equals 1, right? So the answer is just E. So the answer is E. Now, overall, as a mathematical concept, this is what we did right now. This limit is an important mathematical idea. Like, remember your E number, like how do we know it's 2-pointed, right? All that. Well, you can get actually E as a natural number from the limit. So again, this is just a reminder, okay, how we do it. And we actually had really nice 2 concepts here. Actually, I should say even 3. First, bringing exponent down, right? Then we had infinity times 0, so we know how to change this to a fraction. Then we got 0 over 0, that's pure 100% L'Hopital's rule. So this problem actually has everything in it. Okay, so I think that's enough. That's enough. You know, over-learning is not good as well. We should slow down right now. So please learn, practice, look at everything that we had. Make sure you double check everything. Some problems are too easy, except we're not paying attention. So don't forget that. And I will guide you through the process, like for the sketching or graphing. I will give you A, do this, B, you do this, C, do this. Okay, so you will not forget the steps. I think that's it now. I think one thing that we didn't refresh, but I hope you remember the mean value theorem. Do we need mean value theorem? Do you remember what to do with it? And now on your homework assignment, I think there were like 2 types of problems, but overall it's like 1. First, they probably ask you like, can you use mean value theorem and then find C, or find C and if it's gonna work or kind of those things. Don't worry about this on the exam. You will be able to find C. Okay, that's not the case. That's not the problem. But one thing, remember, sometimes we'll get 2 values for C. But you have to be careful because you have to choose one from the interval. Okay, the interval will be given to you. And one thing that I'll put for you right here, the expression from the mean value theorem. But mean value theorem always, what did it say? It says we have 2 hypotheses. The first one is function is continuous on closed interval AB. The second one says the function is differentiable on open interval AB. And then it says then there is C from open interval AB, where f prime of C equals f of B minus f of A over 1. B minus A. And I'll give you the function, and I'll give you the interval. Don't forget, you're not looking f prime of C, you're looking for C. So you're actually working with both sides. What that means, take the derivative of the function, put C instead of what? X, calculate this, and then solve the equation and give me that C. You understand that? Okay? Alright, so Moving along, so I'm gonna make a little change on the syllabus. Right after this chapter, chapter 4, I have a little section from the appendix, the end of the book, which we call sigma notation. I'm going to skip that one because along the way with the process of doing 5.1, we still will learn what that is. So I need to catch up. I need one extra, I should say extra, I need to catch up overall. So I'm not going to do that one. I'll go straight to 5.1. In chapter 5, we call integration or integrals, and you will learn how to find integrals in chapter 5. Now, you're not going to learn all the methods. We've got one, we're using only chapter 6, that's the last chapter that we'll go to, and you will learn just only 2 methods how to find integrals. And if you need calc 2, let's say overall, then you will learn all the methods of integration. So, not too many, only 2, but still we need to know how to. So, 5.1. We'll see how far we'll go, but I'd like to start. So, 5.1 we call areas and distances. So, let's start with the areas. Now, overall, in algebra, let's say, or geometry, we learned a certain set of formulas that we can apply to find areas. If we're looking for an area of a square, let's say, and the side is x, you will say area is what? X squared, right? If you're looking for the area of a rectangle, you will say base times height, or width times length, or length times width. Again, you know the formula. If we are looking, for example, for the area of triangle, you will say base times height divided by 2, right? And then, for example, if you go to a little bit different shapes, more sides, like, for example, pentagon, octagon, hectagon, hexagon, all those stuff, there's also formulas there, but overall it's what? Triangles, right, inside, and you just add areas of those triangles. Now, what's common for all of them, that every side is what? Like rectangle, triangle, every side is what? Straight, segment, let's say, right? Segment. If you want to say line, that's fine, you can say line. So all of them straight. But in real life, it's not always true. You know, like for example, you heard about some lake on the news, and you look at the picture on the news, and you kind of like the lake, and you're saying, well, I'd like to visit. Okay, so you go online and you Google, right? You Google and it says, okay, this is the lake, this is the elevation, and then just all of a sudden it says, okay, this lake has area of this. Well, you normally do not pay attention to that, but what if your lake has this shape? To how well they found the area, right? Like area is this, like what? So how do we know how to find the area, right? Like if it's a rectangle, I can do it. If it's a triangle, I can do it, but we hardly find any of those, right, in real life. So there's some other methods that we're using to calculate areas of these curvy shapes. So that's where calculus will come in. And we're not going to find area of this thing right away, okay? So don't get too excited. It takes time to understand the process. We'll go slow, and we'll get the idea. But overall, to begin with, we're going to obviously apply this to the mathematical concept. That means we're going to use x-axis and y-axis. And then, when we have, for example, something like this is the curve. And to begin with, we're going to talk about area under the curve. So when I say, now you have to be very careful because this is the beginning. Later on we'll say find the area. Right now we talk about find the area under the curve. So what that means, under the curve we understand under, right? But also don't forget it will be limited with what? X-axis. Okay, so please pay attention to this. When we say area under the curve, we have 2 boundary lines or curves. We have curve itself, y equals, let's say, f of x, but also we have x-axis. Don't forget this. It's important. You don't want to be confused. So again, area under the curve. But that means between the curve and what? One more time. X-axis. So please do not forget this. So overall, what you have to understand when we're doing this, at least right now what you see, we need to have equation of the function, okay? And that's what we'll be working with. So to begin, we'll start with simple problem. And at this moment, for number one, we're not going to find the area right away. We're going to approximate the area. So we'll start with the simple function f of x equals x squared. And we'll be looking at this function on the interval from 0 to 1. So I will be approximating area under this curve on this interval. So I'm not saying we find the area, we'll only approximate. So for example, this is just a sketch, okay, so I'm not saying this is exact. So here's my 1. So I'd like to approximate this area. And again, I said under the curve, so again, it's a curve and x-axis. Now we have many methods how to do this. But in Calc 1, and specifically with this book, okay, with this publisher, we're using only one method. We're going to use rectangles to approximate the area. In some books, they're using trapezoids to approximate the areas. Later on, let's say, speaking about Calc 2, you will learn some other methods, for example, like Simpson's method to approximate the area. But here we're going to start with only one. So I'm not going to jump around and do some other methods. So here's our task for now. We want to approximate this area, okay, this area using 4 rectangles. But then something else has to be added here from the right. So we're approximating area of this area under the curve using 4 rectangles from the right. Well, technically what that means is that you also have from the left. Okay, so we'll talk about this in a moment. So before we do this, you have to split this interval into 4 pieces, right? Because we said 4 rectangles. And normally how we do this, we measure the lengths of the segment, right? And divide by what? 4, right? So that means you'll have 4 equal parts. 4 equal parts. And each of those parts will have lengths, what?
X.
No, you know that.
1/4.
1/4, right? This is 1/4, this is 1/4, this is 1/4, and this one is 1/4, right? 4 of them, you get 1. So 0, 1/4, 1/2, or 2/4, right, if you want. This will be 3/4. Now, what are these on the bottom? Each 1/4, 1/4, 1/4. Those will be bases of the rectangle. Okay, base of the rectangle. Now what you do, it says here from what? From the right. So you start from 1 because 1 is on the right, okay? And you start drawing the rectangles. Now how do we do this? You start with 1, go up till you intersect the curve. And then from here, go to the left to the 3/4, and here is your first rectangle. Again, you start with 1 because it's from the right. Direction is important. Then you go up to the curve, and then where you intersect the curve, just go to the left to the next number, 3/4. So this will be the first rectangle. And then you repeat. So you go to 3/4, go up till you intersect the curve, go to the left to 1/2, and draw the rectangle. Then do it again. Go to 1/2, intersect, go to the left, and you have the third one. And now we'll go to 1/4, and you have the other rectangle. Now, if you think about this, let's take a look. Let's talk about this for a moment. Do you think I will have underestimation or overestimation? over, right? Because my rectangles are kind of sticking out, right? I would have overestimation. Okay, but that's okay. So now what do we do here? We're going to find area of each rectangle and then we will what? Add them together. Okay, that's what we call approximate. Now, for this concept over here, okay, for rectangles from the right, we have notation. And that notation looks like this. R will be calling that's our right. And sub 4 means 4 rectangles. So R sub 4 means 4 rectangles from the right. You understand? Okay? So R doesn't mean rectangle. It means from the right. So what we do, now we find area of each rectangle like we said, and we'll add them. Now direction here, which one you will pick first to find the area doesn't make a difference. But normally when we're looking for the areas of each of them, we go from left to right. Again, not drawing the picture, but what? Finding the area, because it doesn't make a difference. You already have a picture. Who cares if you go from left and right? It's still the same, okay? So, we'll go from left and find area of this one, find area of this one, this one, this one, then we'll add. So, if you're looking for the area of this small rectangle, the base is 1 over 4. Remember set distance right here is 1 over 4. But how do you know the height?
Plug that into x squared.
Right, so you take 1 over 4, right, and put it into your function. So you have 1 over 4 times, I should say times, 1 over 4 squared. So that gives you the area of this rectangle. Plus, again you have next rectangle, base is 1 over 4 again. But now I'm going to use 1 over 2 because I'm looking for the height. So I have 1 over 2 squared. Plus, so I have these two done. Plus, we go to the next one. Still 1 over 4 as the base, again the length, so they're all the same. Then we have what? 3 over 4 squared. So this will take care of this one. And the last one again, 1 over 4 as the base, and height of this one is what? 1, right? Height will be 1, so 1 squared. Well, if you look carefully, if you want to make this easier for you to calculate, now you see you have 1 over 4, 1 over 4, right? Can you factor out 1 over 4? So you find the method how fast you can do this calculation. You should calculate, use even the function if you like, okay, to know the values. It doesn't make any difference, as long as you can get it right. So if you do this and keep the fraction, you get 15 over 32. And I'll put the decimal that we can have something to compare. Okay, so 0.46875. So this is the approximation of the area under this curve using 4 rectangles from the right. Okay, good simple. So now I have a simple question. I'm going to ask this right now. I should probably ask this later, but it's fine. Now, well, obviously, this is not exact area, right? And it's really far off. It's not really even close to the right answer. How would you logically get the right answer?
Find the limit as the 4 is approaching infinity.
Right, so we would not say 4, right? Because what is 4? It's number of what? Rectangles. So in the future, in the moment, like in maybe 5 minutes, instead of 4, we'll say n. That will be number of rectangles, right? And then we'll say number of rectangles will go to what? Infinity. And that means you have to find the limit. Okay? So make it simple. Let's say we're not talking about infinities and all that stuff. The more rectangles you put in, right? The more rectangles you put in right here on this interval, the aggregate area will be, yes, no? So if I say, well, let's put 100. Well, obviously it's better, right? If I put, let's say we put 1,000, even better. If I put 1 million, one is too many. Nobody will see them, but it will be better over time. So that's the whole idea. We're learning how to work with simple stuff like 4 rectangles, maybe 6 rectangles, but later on we'll go to the limits and start finding areas using limits. So you see that's a big connection with something that we had before and something that we can now use to find the area. So what we're going to try right now, we actually will do the same thing, the same graph, the same function, but we will go from the left. Now, you really have to know how to draw the picture for the next exam, because you will have kind of similar problem. Let's say our problem is on the next exam, and you have to draw the picture. On WebAssign, again, you'll get 4 problems or 4 pictures, and you have to choose one.
Will you give easily graphical equations, or will they be ones we have to like do all the calculations to graph it ourselves?
No. You get normal graphs. That nothing will be extraordinary there. Again, so we have 1. We're still splitting this into 4. It's still 1 over 4. It's still, well, I wanted to put 2 over 4. Okay, 1 over 2 and 3 over 4. It's still the same, but this time we are talking about L4. So L4 means what?
4 rectangles from the left.
From the left. And you have to draw them from the left. Now, finding area of each doesn't make a difference, but putting the picture, you have to follow exactly what we have from the left. So I have to start from 0. Now, what do you think what's going to happen here if I want to draw my rectangle?
It's 0.
You're not going to have it, right? Because your height, remember you go from the left, right? Now, if you go from the right, you do have height. You understand that? 1 over 4 if you draw it. But if you go from left, which is right now 0, you have no height. So I'm going to just draw this horizontal little piece a little bit, let's say thicker here, just to show you that there's still something, but no rectangle. Now here, I go to 1 over 4, right, that's my next number, and I'll go up, intersect my curve, and then from this curve, I go to the right, to 1 over 2. Again, going to 1 over 2, I'll go up and intersect the curve. I'll go to the right. Repeat this with 3 over 4, and I go to the right again. So what do you see here? These rectangles where?
You're really going to shoot this from here.
Below, right? These rectangles below the curve, and this will be what? Really what? Underestimation, right? Can you see that? So, here's well, this one there's no rectangle, but right here, 1 rectangle, here's another rectangle, and here's another rectangle. Okay? And let's just work with this. So, the first rectangle, I'm still going to call it first rectangle, okay? It's still 1 over 4 because the base is 1 over 4, but there is no height, so it will be times by 0 squared. Do you understand that? There's no height for this rectangle. Then you're going to add, moving to this one, so you have 1 over 4, and the height will be at what? Now again, the first 1 over 4 is what? It's the base, yes or no? 1 over 4 is the base, but then you have 1 over 4 as the number to use for height. So you get 1 over 4 squared plus, moving to this one, you get 1 over 4 as the base, but then what? 1 over 2 squared, right? And then what? Plus 1 over 4 again, and what do you get? 3 over 4 squared. This is what we have. Again, using your calculator, I'll go faster here. We'll have 7 over 32. And if you go to decimal, we'll get 0.21875. Well, so overall, if you think, area is where? Somewhere between, right? Yes, no? The exact area. Okay? Now, one thing what I want you to look, okay, let me kind of move this stuff around that you can see. Now, if you pay attention, if you go from the right, you use 1, you use 3/4, you use 1 over 2, you use 1 over 4, but you didn't use what? 0. If you go from the left and look carefully, you use 0, you use 1 over 4, you use 1 over 2, you use 3 over 4, but you did use what? 1. Now this is important, okay? Specifically when the picture will be more complicated picture. I don't want you to think that every graph is going to look like this. Okay? Because if you look carefully at this graph, what do you see? It's increasing, yes, no? So if your graph is increasing on this interval, then definitely you will have what? Overestimation if you go from the right. If it's from the left, you will have what? Underestimation. But what if, let's say my graph is decreasing? Then everything will be reversed, yes, no? If my graph, let's say, will be like this. Right? So this will be no rectangle here, but then you go over here, this is what you get. You understand that? So this is from the right. So now from the right is what? Underestimation, right? If you go from the left, you will have what? You have overestimation because we're on the top. But what if you have mix, increase and decrease? In that case, you cannot say. Okay, it just will be approximation. Because one rectangle will be above, the other one will be where?
Below.
Below, right? Depends on the curvature. So that's why you have to learn how to draw the picture, not by Bassam giving you 4 choices and you deciding which one to pick. So those are important things. And one more, and you're going to say, what is one more if you go from left to right? Well, I'll show you what one more is. So the same thing. This is 1. Now what is one more is this. I'm going to write and we'll talk about what that is. It's M4. So L is from the left, R is from the right. What is M? Middle. But we don't say middle, we say midpoint. So M4, it means we're going to use midpoints. Now, but still what? 4 rectangles, right? So the setup doesn't change. You still have to split this into 4 pieces. You still have to split this into 4 pieces. So you still have 1/4. You still have 1/2. You still have 3/4. Nothing changes here. But what will determine the height of the rectangle is the midpoint of each interval. So that means I'll be right here. That's the midpoint of that interval, yes, no? Right here. And this will be what? 1/what? 8. Here midpoint will be 3/8. Here midpoint will be 5/8. And here midpoint will be 7/8. Now I want you to pay attention. I know I put so many numbers, but please remember, midpoint will not change the number of rectangles. We still have 4 of them. The only difference what we have right now is that we are using 1/8, 3/8, 5/8, and 7/8 as the number to determine the height. And what I'm saying here, pay attention. And left-right doesn't make a difference here, okay? So that's not the problem. So let's start with here. I use 7/8. I'm going to go up, but I'm not going to drawing anything because I don't want to have too many things. From 7/8, I'm going to go up to my curve, and that's where I get my intersection. And then through this intersection, you put the vertical line, and this is what we have here. It's still from 3/4 to 1. Do you understand that? It's still this thing, but the only difference right now, the height of the rectangle will determine the midpoint. The same thing here. You go from 5/8 goes up, and then through this one you draw the line, and here's your rectangle. Same here. And the same here. So we have 4 rectangles, okay, using midpoint, but here's my question. What do you think about this one? Out of all those L sub 4, R sub 4, and M sub 4, which will be the most accurate? M sub 4, right? Because you're taking piece from the top, but from the bottom you're kind of like compromising, okay? So, when you do this and write this, the base is still 1/4, 1/4, 1/4, 1/4. That doesn't go anywhere. And if you want to factor out, that's fine. I'm just showing you the substitution. And then over here, what will determine the height of the first little rectangle?
1/8.
1/8. So you put 1/8 squared plus 1/4, 3/8 squared plus 1/4, then what? 5/8 squared plus 1/4 and 7/8 squared. And again, giving you the answer, if we put this in, we get 21/64. And if you put decimal here, you will have 0.32825. So you see this one like almost in the middle. I'm not saying the average. It's very dangerous to say average, but it's somewhere there, right? So this is the most accurate one that we have. Do you understand the concept? The idea?
Yeah.
Okay? So, any questions? Okay, so what we're doing right now, again, we're not really looking, actually, well, I'm looking at the clock right now, okay, and I know I'm not going to finish, so I'm not going to even start. But the next step, what I have, and we'll do this on Friday, okay, so tomorrow no class, okay, we'll do this on Friday. I actually will show you how through the limit we can find exact area, okay, through the limit. We're going to find exact area. But in order to do this, we have to set up special formula to get this right. Because again, you have to understand if using n rectangles, you really will never know what you have over here because it's a big piece, right? It's a big n. So I'll show you how this can be done. So that's it. So keep working. Concentrate on those areas that I told you to concentrate and get the idea again. Try to maybe change some concepts that you had wrong, memorize or something. Look at the formulas again for the derivatives. And don't forget, be careful with antiderivative because you are going backwards, right? Also, if you need multiple, let's say for antiderivatives, if you need multiple constants, then just use what? C, D, E, F. Or if you want to use what? C sub 1, C sub 2, it doesn't make any difference. Okay, so no graphic calculator, again one more time. Use scientific. And remember what I told you yesterday? I think I said, for the Newton's method. Try to use your scientific calculator. Don't use your graphic calculator. No. Sorry. When I say Newton's method, I'm not talking about solving. I'm talking about something that you will have on your exam to find like x sub 2, x sub 3, those, okay? Try to use your scientific because you have to feel it, how that's going to be. Because you're not going to hit enter, enter, enter. That's not going to work, okay? So please,
It doesn't mind.
try it.
How many digits does it ask for the test?
Well, I don't know, but obviously I'm not going to say all of them because I don't know, like it depends maybe scientific calculator. But one thing what I would say, if you know your scientific calculator well enough, get to menu and change the decimal approximation to float. Okay? Because what float means, calculator just gives decimal as it is to fill the space. When you put float 1, it gives you only one decimal place. If you put float 2, it gives you only two decimal places. Just put float. Okay? I don't know, I have no idea how to.
We want to thank everyone for coming up and amazing. Or ninth grade.